Welcome everyone to Optimizing XML and JSON Workflows for Seamless Data Integration. Tame your data monsters because XML and JSON don't have to be scary. As you can see with our logos here, we have a bit of a Halloween theme going on today. Having some fun with it with Halloween tomorrow. All right, so today I'm joined by Kaylin and Dean as our presenters. I'll pass things over to Dean to introduce himself.
Yeah, hi. So I'm Dean. I am the team lead for strategic solutions, and then I'm also the product manager for open standards. Yeah, I know open standards can sometimes scare people, but yeah, happy to help if you have any questions along those lines.
And hi, I'm Kaylin. I'm on the FME forum support team. You can find me on cases or helping out on the forums.
Awesome. And we do also have Trent joining us on the back end. So if you have any questions whatsoever during the webinar, please do drop those into the questions tab, and he'll be keeping an eye on that to help us respond. And right off the bat here, we do want to give a little shout out to our peak of data integration that's coming May 6th to 8th of this next year in Seattle, Washington. Abstracts are still open until November 29th, so be sure to get those in for the special speaker rate. We hope to see you there. And before we dive into the webinar, just quickly, if you're new to Livestorm, as I mentioned, the questions tab, drop any questions there. The chat on the bottom right, keep letting us know where you're tuning in from. And we do have a poll coming up shortly, so actually very shortly, under the polls tab on the bottom right. And if you have any audio issues throughout, please click that help button on the bottom left for 4 simple steps to take. And if you wish to download the deck, you can click that top right button. So we're diving right in with our poll here. We'd like to know, what do you use more? Is it JSON or XML? Or maybe you have yet to try out either, or maybe you use both equally. So I'll give everyone a moment there. Dean, Kaylin, do you have any hunches as to what might be the winner? No peeking.
That's tough. I think it might be XML just because XML might need more support, more work than JSON. That's just, it's got a bit more history. So I'm leaning towards XML, but.
Okay. Okay, we know that Dean did not peek because it's actually JSON. Half of the audience, and then another, I should say 40% either use XML or both equally. Yeah, that's great. XML more or both equally as much. Thanks everyone for letting us know. That definitely was great insight for us. All right, so at this point, I will get our presenters to turn off their webcams, and I will pass things over to Dean for our agenda here.
Okay. Very good. My audio is fine right now?
Sounds good.
Yeah, you sound good.
Perfect. Okay, so yeah, we'll take you through a range of topics here around XML and JSON and what some of the challenges are, and then the kind of tools that FME has to help you address those. So we've got quite a bit to cover today, and I'll dive right into it. But we also have a lot of resources and the deck, and all of these examples will be available for download after. So I'll just give you a bit of an intro to XML and JSON, and then some comparison and contrasts, as well as looking at the FME toolset. And then I'll hand it over to Kaylin for some live demos, flash demos, and then I've got a few myself. And then we'll wrap it up by looking at troubleshooting and best practices. So just a quick word about the FME platform. So FME is an enterprise integration platform where you can author your data integration transform workflows on form and then publish those to Flow. And that can be on-prem or in the cloud. And yeah, any questions about the platform? I think while we're on this slide, certainly working with JSON and XML is key for enterprise integration, because a lot of essentially that underpins a lot of the messaging and services that are involved in enterprise integration are built on XML and JSON. So our goal here really is to help you work with any API and save time with the work that you have to handle, extract, and validate XML and JSON. So then you can focus on your applications that you're trying to build. Yeah, I guess one of the main challenges is that we have the XML and JSON are object oriented, so that you have basically you build up objects and you have nested objects. And so dealing with that nested data in relation to things like GIS or databases can be a challenge, because you have to, if you're going to load it into a database, you have to flatten it. And then if you want to compose an XML or JSON message, you have to repackage it in that object structure. So that's the core challenge, one of the core challenges. And then there are other wrinkles, like with XML, things like namespaces, code lists, number, so whether you have one or many, and data types. And then, of course, validation itself can pose challenges. Sometimes JSON is a little harder to validate because you don't have schema. And then the whole goal here really is automation. So a lot of these, as I mentioned, XML and JSON workflows, and be able to automate those. But without FME, you might have a lot of different scripting tools that are hard to combine or integrate. But you don't have to face these frustrations alone. So that might be a scary world out there with all the XML and JSON that you have to contend with and APIs. So FME offers a streamlined solution for handling this. And we'll have lots of examples here of how to face some of these challenges. So basically, in terms of the comparison and contrast, so they both are based on an object model, like I said, but XML is more schema specific, more tightly structured, and has those quirks like code lists and namespaces. In XML, we talk about elements and properties, and we usually mention a JSON object. That's what JSON stands for, JavaScript Object Notation. Yeah, some of the terminology can be a little bit different, but the basic idea of a nested structure is similar. Yeah, so JSON's a bit less formal, more flexible, easier to implement on, and it's typeless. It doesn't have prescribed data type. But the one thing that's missing here is that it's actually harder to validate. So the XML is easier to validate and JSON is harder. So why are we even talking about XML and JSON? As I mentioned at the bottom there, they're both foundational technologies. A lot of enterprise automation and web services are all built on JSON and XML. The core concepts really haven't changed. So we have some links, some of the articles and webinars that we link to might be a few years old, but the core concepts really haven't changed. It's just their uses, how we use things, maybe doing things in the cloud now. So the applications might change, but the core technology is the same. And yeah, many open standards are encoded in XML, JSON, and GML. Things like ideal for standards like OSM, Inspire, AXM, and a lot of national mapping standards are using XML as well. So yeah, specifically XML is used a bit more where you have a prescribed schema or a complex geometry, so that it's easier to manage that in XML. JSON is more for streamlined REST services, lightweight, like web apps, mobile apps, and things like IMDF for indoor applications. Yeah, so I think I covered most of that. So why don't I hand it over to you, Kaylin, and we'll kick off with a flash demo.
Thanks, Dean. So here we're going to do a quick flash demo to set the stage. We're going to use a HTTP caller to hit the National Weather Service API endpoint and return a weekly forecast for an area near Sunshine, California. So we're first going to use the API to return JSON, and then we're going to update the header value in the HTTP caller to change the response format to DSWL, which is Digital Weather Markup Language. Digital Weather Markup Language is a flavor or an XML specification. So I'm going to go ahead and share my screen. Everyone should be able to see FME form. Okay, so because we don't have a reader to kick this workspace off, I'm going to type and add a creator to the canvas. When there's no reader present, a creator can be used to initiate the workspace. Now we're going to use an HTTP caller, and the HTTP caller is actually going to interact with the API. Here we're going to supply a request URL. So we have our API we have our grid point, we have the closest weather station, sorry, the grid point, and then what we're actually requesting from the API, which in this case is a forecast. By default, this API will return JSON. So we're going to go ahead and return that JSON first. And we can take a look at the output. And now if we change the header value in our HTTP caller, so we'll accept, and we're telling it to return DWML now, and we rerun, we'll see we're getting the exact same information, but we're getting it back in 2 different ways. So now we have a JSON response. Awesome. So just to review what we did, this demo is meant to show you how similarly JSON and XML can be and are used in industry. So by changing the accept header value and the HTTP color, we can dictate what format the API will respond in. Taking a closer look at the outputs, we can see they're structured very differently. So the XML is grouping the returns by kind of value. So you're getting all of the day and then all of the wind speeds and all of the temperatures, whereas the JSON is returning the day and then all of the information that corresponds with that day. Okay, so now using XML and JSON and FME. So XML and JSON are virtually found in almost every industry. As we can see, there's no shortage of applications for these formats. So they're used in everything from mapping to utilities and transportation. We refer to these as flavors or fixed XML or JSON schemas designed for a specific industry or application. So you might not have known that markup languages can also be used for more generic things, not in industry like web scraping or streaming. So HTML can be converted to XHTML and parsed accordingly, or GRSS can be used to create stream feeds, whether that's for vehicle management or fleet tracking. Although we do offer JSON and XML readers, we like to encourage users to use a designated format reader if there is one available for these formats. So they're going to have more parameters and built-in functionality to help address format-related encounters, if you will. So for example, if I was reading a topo.json file into FME, I would use the topo.json reader instead of the JSON reader. It will just, the more specialized the reader is, the richer read you will get. So looking at the variety of these formats, most of these are XML, but there are a couple JSON ones in here. So city JSON. And so there's 3 ways to write JSON in FME. Firstly, we can use the JSON templater, which will be schema unaware. We can write JSON with the JSON writer, which will handle data by row. So there's not going to be any nesting or data type support. And then lastly, which is actually in development, we will be producing a schema-driven JSON reader writer. Dean, I don't know if you want to touch on the OpenAPI aspect of this.
Yeah, thanks, Kaylin. Yeah, so basically with XML and GML, you will notice that we've supported writer-side schema for quite some time. So if you go back a decade or so, we had to use the templater and text line writer to write any XML or GML. And then we added support for the application schema-driven writers. And the difference is, instead of just having a big XML blob, you actually have fields and data types on the destination. So right now with JSON, you still need to use a templater and a text file writer. So we're going to add support for JSON schema, and so that you can pull in nested objects, series or lists, and blobs if you need them. And that also will be key to supporting things like OpenAPI, because OpenAPI, when you can ask for it for a list of methods, and then you can ask for a list of data structures that are supported. Yeah, that's one of our key development things on the horizon, on our roadmap. And if you have any interest in that, let us know. So if you want to be kept in the loop, or at least have some input in terms of how we do that, feel free to contact us. And then any other enhancement ideas, where we can talk about it in the Q&A, or you can let us know.
Thanks, Dean. So now looking at kind of the XML lens of this, we do have a XSD-driven XML reader and writer. So what is an XML, or an XSD XML file? So this is a schema definition file. So an XSD produces or enforces guidelines or rules on how XML or markup language data is exchanged between applications or devices. So like Dean mentioned, they usually include things like code lists. It will tell you what elements are optional or required for your data model. It will tell you how many expected children features there are from the root and what values are going to be restricted. So if there is an XSD available for the data that you're working with, we highly recommend using it. So to avoid using the XML templater, which is still useful in particular situations, we can use XSDs. So the main idea behind the XML templater is you're going to have to know the exact data structure of the data set that you're trying to produce. So you're going to have to know the exact structure and types. Now we're going to use FME to read an Excel or a CSV file and actually create our own XSD. And so maybe we're working with the same kind of data repeatedly, or we want to even validate the same kind of data that we're working with. This is how we could possibly do it. So I'm going to share my screen and hop back into FME form. So we have our reader feature type here. We have our business owner spreadsheet, and we have a couple customer information. So we have a lat long value, some names, and a license number. Really, the only thing I'm going to do here before we push to XML is update this first name so that everything is aligned. So we can do this with an attribute manager. We're going to rename first to be first name. And now we're ready to output. So we're going to go ahead and add an XML writer. So you'll notice that we're not writing the XSD XML, we're just writing to XML. Our business owner spreadsheet is being written to our output folder. And I want to highlight the parameter down at the bottom here. So this suppress XSD output, when this is set to no, the writer will actually create an XSD based on the data that's being written. So we're going to hit OK. We're going to rename our writer feature type. Connect. You can see that the writer is picking up that name change, and we can go ahead and write. Our log file tells us it's a successful translation. And now we have an XML file and an XSD in our output folder. If we take a look at this XSD, we can see we have all of our attribute names, we have the type, and we actually have a max length value too. If you produce this and you need to edit that max length value, you can go into the writer feature type, you can change this, and then that width will actually control the size limit, or sorry, precision. So now that we have this, we can reread our XML. You'll notice now the format reader is picking up the XSD-driven XML because the XSD is contained in the root folder. Oh, sorry. So we have our XSD already mapped here. And then for the feature pass, we need to actually select what we want FME to read. So in this case, because I want all of these attributes, I'm going to select the top root element or parent element, and then we'll click OK. So now when we read this in, we'll see we have the exact same data from our spreadsheet in a different, coming through as XML. And that is how you would produce and consume XSD-driven XML and FME. So we just did the demo. So there we used a CSV to generate an XSD schema and XML dataset, and then we were able to reread that XML as XSD-driven XML. So just taking another look at our XSD. Okay, so the last thing I'm going to talk about is our XML and JSON transformers. So as Dean mentioned, we have a very comprehensive tool set. We have transformers that will update, fragment, flatten, validate, and we'll get into validation later during the troubleshoot section, but I'm going to show a demo of how all of these transformers can be used in tandem to actually extract features from an API response. So we're going to jump back in at the, okay. So we're going to work with that same API response from the Flash demo. So here we can see we have that National Weather Service API return. And so I just want to get familiar with the return before building out the rest of this workspace. So if we look, we can see features. We can see a feature is storing our properties, and properties has many periods. And so we have a period pretty much for each day in the forecast, and that's what we're going to want to extract into features. So to do this first, we're going to add a JSON fragmenter. And the goal here is to create one fragment per period in the response. We're going to point our JSON attribute at response body because that's what's storing it. And then we're going to want to update this JSON query. So right now, this would only return the single top feature. And so we want to dig into the JSON. So here we're going to dig into properties and we're going to fragment on periods, and we want all periods. So when we do this, we should see about 14 features returned. Look at the output. We now have a fragment for each JSON period or period. So this still doesn't look quite right. We need this more tabular. So now we can actually flatten our JSON. And so what we're going to do is send all of our response bodies to a JSON flattener. We have flattening is yes. We have no additional parameters to set there. And we can see how our data has changed. So initially, it doesn't look like it's actually done anything, but if we click this, we'll see our feature information window now has a whole bunch of unexposed attributes. And so all we need to do is unexpose them to get them into our table view. So we can go ahead and add an attribute exposer. We could select all of the attributes that we want, but the faster way to do this is to actually import from feature cache. You'll notice that all of our feature cache, attributes are auto-selected, and we can nicely click import. When we click OK, we'll now see our attributes in the table view. So we can now remove the fragments if we don't need them, or etc. One thing I do want to mention that's maybe people don't know is that this step is actually not necessary. So there's a lot of ways that you can do the same task in FME. So if we just disable this and we come back into our fragmenter, there's an option under the flattening settings to actually flatten and fragment at the same time. And so if we rerun this now and look at our feature information workspace, you can see that we can skip that flattening step, reduce the transformer count, and still expose the same information. Again, that's one way. We also could go right to a JSON flattener and then use a list exploder, and we would get the exact same results. So lots of ways to do the same things in FME.
The other thing, just to jump in, Kaylin, I wanted to emphasize while you have this up, if you go back, just looking at the table view right now, you see that response body. So that's pretty big. And so there are different stages along here where you probably want to use an attribute keeper or attribute remover to get rid of some of the lists or JSON blobs after you've done your flattening. When you do your flattening, keep just what you need. Otherwise, your memory footprint's could grow exponentially. So it's just something to keep in mind.
No, that's good. Good point. Okay. Thanks, Dean. So this is just reviewing what we did. So we can flatten with the fragmenter, and we can use the attribute exposer with that import function to import from our feature cache.
Yeah, and there are also ways of, you could use the flattener at the beginning and then have a list exploder. But I find the fragmenter acts almost acts like a JSON or XML reader. And so I find that's more intuitive for me. Okay, so Kaylin, I guess this is me. I'll take over.
Yes.
Yeah, thanks for those great demos. I'm going to start with a blank workspace here, and I'm going to do something novel. So we were chatting about what's better, XML or JSON. So I'm going to actually convert from XML to JSON here. And I'm just going to use the regular old XML reader. I'll forget about the schema for now. And so we're just going to go look for an element to match. And you'll notice here, I'm going to choose the alert and the info. So the first point I'm going to make here is don't do this. If you do this, it's going to make a feature type out of every attribute or every property. I know sometimes it's tempting when you see a select all just to grab everything. But generally, we're just looking for what's going to be a feature type. So that'll just drop down these two feature types, and we can see what's in there. So we've got, what am I working with? This is the common alerting protocol from the OASIS standard. And so my goal here is, this is cool. This is an XML, but popular feedback suggests people want this in JSON. So what would a cap message look like in JSON? Now, normally what you want to do is start with some sample JSON, but let's say all we've got is XML. So I'm actually going to use our JSON writer, even though often we don't. Normally, as I said, we normally use a templater, but there are occasions when flat JSON is good enough, and this is one of them. So then what I'm going to do is duplicate these on the writer. And so we don't need the new. And then I'm also going to do is set this up just to be automatic schema, because we're going to modify. So the first thing that we don't need is all this XML stuff. So I just type BAR for bulk attribute remover, and I put in XML. Notice that the XML stuff goes away. We'll do the same thing over here. And the other thing to keep in mind is, yeah, we don't need the duplicate information because all the info is on the right, so we can get rid of the info on the alert. So I'll run that, and that's going to give me sort of the primitive JSON that I can use for my templater. So if I go here and I look at what was just modified, so you can see I've got, I should try to zoom that a little bit. So you can, I've got two records here. The alert actually comes second. So I'm going to use this as the root of my template. So now I've got a workspace that's already been completed. So we'll pop that up. Now, normally what I would do is I would just drop down the JSON templater and open that up and put this in as my root template. And then I would have the process of, I'll zoom in there a sec, but I would basically, I got to hook this up anyway. Let's say this was hooked up here. And let me zoom in a little bit. So then I would have this process of paste in the template, and then for every field that I actually want to be dynamic, let's say the address, I don't want it hard coded, then I would just double click on the FME attribute function, and that will drop the function in. So it's like a mail merge operation. That's how templater works. And then of course we can do things like add a sub template. So I've done all that here already. Now, I'll just show you quickly what this looks like. So we've got, it's always alerts. I didn't bother changing that, but I've substituted in the attributes that are coming in from the XML. And you can see I'm merging in the identifier and the author. And now this one's really key here. This invokes the sub template. So this process features sub. And so to make the stuff that goes in the sub template, we just read the info records. We only have one info record. So then what I do is I end up creating a copy. And before we do that, I also added some parsing here for the polygon because it's just a bunch of coordinate pairs. And I want to reformat that into GeoJSON. So I actually make a GeoJSON fragment here. And I'll just show you a little trick. I had a bunch of errors when I was playing with this last night, and with JSON, it's almost 90% of the time it's brackets or parentheses, and so I noticed that I only had two closing here, and I actually used a creator to make a dumb 1, 2, 3, 4 box and a geometry extractor into GeoJSON, so I could actually compare, and it's like, oh yeah, that was wrong. So that's how I fixed that problem. So this I'm actually making so this is like almost like a template for the geometry. So that's actually a GeoJSON string. So ultimately then what I'm doing is that's the one record I used as a template for the root. And then I had another JSON object I used for the multiple info records. And you can see here I'm pulling in the geometry here. Now the trick here is I've got a get JSON attribute. If you try to do get JSON, it's not going to work out very well Here, I'll break it and I'll show you what it looks like. So if I look at the output now, you get this weird escape stuff, and that's not valid GeoJSON. So that's when you get these escapes, and this happens in XML as well, you're not using the right function because the function is not set up to handle JSON or XML. It thinks it's a string. So to fix that, I just got to go in the template and change that back to get JSON attribute. And those functions are all available here. So the XQuery functions. So interestingly, even though we're in JSON, we're using XQuery. Go figure. So that's gonna look okay there, and then I should be able to fix that. And then of course the ultimate test on any of this stuff is there. Now you can see it's got a XML fragment. The ultimate test, if this worked, is to actually go to your output and read it back in. So if I go here and I open that with Data Inspector, now there's a little trick here. This is not, again, this is not really GeoJSON. It's this nested structure, which is more complex. So we have to use the JSON reader. But what we can do is we can use XQuery to drill into that. So the root becomes the alert. And then I drill in here and use the tree control to pick the array because I want each array element to be a record inside the info. And then the other trick is the geometry format is GeoJSON. And then I have to specify the property name, the property key name in order to render the geometry. So we'll go ahead and grab that and see what happens. Oh, and the last thing I did wrong here was there is a way to, oh, yeah, you have to specify the coordinate system. Yeah, I guess I did do that correctly. There you go. So we have one alert area for the Fort Langley and one alert area for Maple Ridge. So that's going all the way from XML to JSON. So anyway, that, if I went a little bit quick, that's all available on when you download the demos. Great. Okay, so now I gotta flip my screen. So I think I covered everything there. Yeah, the last thing here, filter out unwanted attributes, and that's what I use the bulk attribute removers for. And yeah, there's creating the GeoJSON and using the sub template. So that pattern, and then finally, of course, writing it out. I didn't really get into the details of the JSON validator. It's really just checking syntax. And the formatter, the pretty printing is always handy because if you do get an error message, it'll give you a line number and a row number. And if you just have one big long string, that makes it very hard to diagnose. But when you actually deploy to an application, you probably want to serialize your JSON because it'll take a lot less space. All right, so now we're going to jump over to, yeah, that's just the subtemplates. And there's the result. So we're going to look at some sort of real world use cases here. CityGML is probably one of the biggest applications for GML that I've seen. There's tons of data. You may not, it's not as widely used in North America, but I will show you some stuff from Canada. But it's used extensively in Europe and Asia. And there's CityGML 3 that we support the reader on, and we'll soon have a writer for. So as an example of this, we have our friend from Pacific Spatial, Takashi, and he has worked on this plateau project for a number of years in Japan, and they have something like 120 cities that have been modeled. And there's an example of some of the output. Yeah, it's pretty impressive what they've done. And maybe in the Q&A, I'll pop up what that looks like. But in the interest of time, I'll keep moving. So I wanted to show you back to my screen here. I want to just quickly show you, I know Kaylin mentioned this, but it's handy to actually see an example of it, of why we talk about reading more specific and then getting more, if you start general, so you could read this. This is the Montreal data set for CityGML. I could read this with the XML reader just by saying split it at, is it flip fuse? Anyway, I split it at group member in the CityGML, city object member. But then all you get is this table view. There's no geometry. So the XML reader doesn't give you geometry for free. The geometry properties are in there, but it's all embedded as these XML elements. So then you could use the GML reader. This is a little tricky because here when I did the GML reader, I actually have to use the mode ignore application schema. So sometimes if you have trouble with GML reading and it's tripping you up, you can try ignoring the schema and see what happens. And so here you can actually drill into the data set, and it's pointing at the wrong path, but if you drill into the data set and point at building, you can actually read that entire data set as GML. And so when we look at that, we can actually see geometry now, but it doesn't have any of the textures. Yeah, flip the 3D mode here. So then if to actually read this as CityGML, we need to use the CityGML reader. And that will actually read all of the textures, and let's take a minute for that to refresh. Yeah, I think it'll come back. It's taking a bit to wake up. So if I flip back to the deck here, you can see what that looks like. So this is, oh, and then I have the same thing over here as CityJSON. So CityJSON is another encoding of, it's the CityGML model, but encoded in JSON. So it has some advantages. It's a little more lightweight, and so it's faster. It doesn't have to do a schema scan, and it might be better for some thin clients. There's a bit of a debate in the CityGML community as to which one's better, but I guess it all depends on your application. So this is a Montreal data set, and so now instead of just 3D buildings, we have all the textures. And then the other thing you'll notice is that these buildings all have their CityGML properties as well. Okay, so talking about NextGen 911, we've got a number of customers that are working with NG 911. And the whole point of NextGen 911 is to basically get us ready for move the whole analog system into a digital backend based on IP, on Internet Protocol. And so that's actually going live in Canada in March already. So that's on the comm side. And then in the next couple of years, all of the data, the GIS data to support that for things like geodetic call routing and actual routing, the responders. So all of that's going to be in play very soon. And so our friends at Santa Clara already have a number of FME workflows that have helped them do a lot of cleanup of their addresses. So basically a 50% increase in the number of known addresses. And that, of course, is going to be crucial in terms of a life-saving response. I'm going to run through a really quick demo here. I've already got this built, so it'll be pretty fast. So basically here, what we're doing is we're reading from a CSV file and writing to XML. All right. So I just wanted to show this workflow and show that we're going to break it here. Without a root element, we can get errors like duplicate roots and things like that. So number of roots, 9861. And the problem with that is that XML actually requires a parent ID. And we create a parent object here with XML ID 101, and then I'll rerun that. So that validates, and then we can look at the output. So this is the output here. So basically, that's that CSV file converted into CLDFX. So that's the CLDFX is the civic address data exchange format for NENA 911. And so you can see here are all the streets. It's a pretty flat structure, but just showing you how that can be generated. There is also a geodatabase template for NG911, but that's ultimately based on this XML schema. And so the trick here was I filtered out things with invalid street numbers because they're not going to be valid NENA records. And so obviously somebody has to deal with the failed features as part of a QA cleanup. And then here we're just populating the values from the CSV file. And because we're using the XSD-based writer, we don't have to use things like a templater. We just have to define the feature path. And there's two things here. We have a feature path for the collection and then civic address for the feature types. So those are just the steps in that transform process. And we're using the XSD XML writer, both to import the schema and also to validate. And that's what the output looks like, which you just saw. A few other quick things. I'm going to, in the interest of time, I'm not going to bother reopening my data inspector. We've got some screenshots here. We're going to talk briefly about Finavia and Spatial World. So they're working a lot with AIXM. And so that's reading from their National Land Survey and PostGIS, and then ultimately generating AIXM. And so basically all I was going to show here is that AIXM, we support a number of versions of AIXM. We have the 4.5 reader, which is based on, I can show you what that actually looks like. So if I flip my screen here. So this is AIXM 4.5. And you'll notice that there's no obvious geometry. It just has these parameters of things like the runway length and width. And then the workflow that's in the demo lets you convert that to GML. And so one of the tricks when you get a data set, you can actually look at the namespace and figure out that this is in fact AIXM 4.5, not GML. The same thing goes for here. If you look at the namespace header, you can see that it's 5.1. and that it's actually GML. It's all in the namespace header. So those are useful clues. So here, if I run this, I'm going to get an error because I have validate on. And so this was a bit of a quirk that came up for some reason, upgrading to the latest version of FME. The geometry property setter behaves slightly differently. And so I'm getting these errors saying this ID is not unique. And if you look in there, the GML ID gets repeated. So to fix that problem, I had to create a new prefix on the GML ID for the polygon. And then I use this geometry property setter, which says for the polygon, set the GML ID in that geometry from that attribute that I just created. And so now when I run it, it validates. So successful. So that's the workflow, which basically just takes the AIXM 4.5, all those parameters about runway length and angle and width, and it generates a geometry, does the schema mapping to the AIXM 5 standard here in the copier. So it converts between those two standards and then ultimately builds the geometry and writes that out. Yeah, just to wrap up, a couple of thoughts on troubleshooting and best practices. We've got other examples here. You saw there when I had the wrong get expression, it corrupted the GeoJSON geometry. So that can be one issue. The other thing is sometimes when you get the geometry wrong or the element wrong, it simply doesn't write anything out. So the problem where I showed you I didn't have a closing bracket, it would just say geometry equals none. Because it just rejects bad syntax, but it didn't actually say anything in the error log. So I actually had to go through and check things. So Notepad Plus is your friend. You need to look at your input, your output. Sometimes you need to turn validation off just to generate output so that you can examine it. And so don't be shy about using Notepad++. You need to install those XML and JSON tools to that so that it formats things properly. Yeah, with XML, having multiple roots is a problem, duplicate IDs, bad namespaces. So if the namespace, if there's any one character difference in a namespace, it'll consider it a different namespace. And then missing parent-child relations. So you will get orphan children if the parent ID, there isn't a GML ID equal to the parent ID in your data set. And then the last thing I want to emphasize on this slide is this thing here. Element sender is not on the bottom right here of the slide. The error message says element sender is not allowed for a content model. So that actually doesn't mean that sender isn't allowed. It's just not allowed in that order. So if I went and deleted the GML identifier or ID, the reason why it says sender is not allowed, it's not allowed until you get a ID first. So it's not it's a bit counterintuitive. And so we've got our resources on validation kind of cover and give you lots of examples of that. We don't really have control over the exact structure of that message because that comes directly from the third-party library that we use. Yeah, so just to remind you some things we've already talked about, attribute remover or keeper to improve performance and avoid memory bloat. XSD types is generally better if they're available because you can just check one type. In this case, there might be a type called thoroughfare, which actually reads trails, streets, and roads. If you use feature paths, you have to explicitly select each of those element types. Pretty printing so that you can actually get better diagnostics. Validation, you normally start with syntax, then add namespace, then add schema. And reading back is the ultimate test. So can you actually read it back? Just like we read that GeoJSON and got the actual geometry. That's how I knew I built the GeoJSON correctly. Check your logs, probably starting at the bottom and going up because logs can be long and generally the errors are near the bottom. And often there's more than one way to do things. Like you saw, I read that CityGML 3 different ways. So I think I'm out of time. So just to wrap up, FME helps you address challenges of working with object-oriented formats like XML and JSON, integrating them both directions with going to and from relational models like GIS. We allow you to easily access your data and generate it so you don't have to spend as much time wrangling it, but you can focus on your apps. And yeah, XML and JSON are foundational to enterprise automation. And yeah, automation is really key when you're building these workflows because it helps avoid human error when doing things like interpreting schemas and transforming the data. And FME has tons of tools to support validation and diagnostics. And we're continually tracking new developments, OpenAPI, CityGML 3, OGC APIs, JSON schemas. You don't have to track those all yourself. So I think that's pretty much it. Just a couple words about SAFE. I guess you guys all know who we are, and we've been probably doing XML stuff now for at least 25 years. So we've got quite lots of experience to support you. And people are using our tool sets right around the world. And we got in the sort of the top right quadrant with Gartner as the kind of customer choice award for data integration tools. So that's not just spatial, but it's all types of data integration. And here you go. Here's the resources. So we have a lot of tutorials, and there's also webinars that you can view. And so dive into more detail. If you want more about XML, there's the XML-a-thon. And the JSON webinar actually has a bit of a Halloween theme as well, Scary JSON. So that's pretty much it. And then there's lots of stuff on the hub as well.
Actually, I just one more thing to mention. I think around February 5th or early February, we should have an NG911 webinar being debuted, to keep your eyes open. Yeah,
that's correct. Yeah, so Accelerator, in other webinars, there's one on Esri AGOL metadata coming up later in November. Any questions? I guess we got a couple minutes here. If you do have to step away, thanks for your time and thanks for joining us. Like I said, all the slides and demos will be available shortly and attached. But yeah, Trent, were there any questions that sort of jumped out?
Yeah, it looks like Trent highlighted a couple here, though we did get to them all. So if you are not able to stay with us for a minute or two longer here, thank you everyone for joining us today. We really appreciate your time. But yeah, we can just highlight here maybe one of the two from the questions tab there. Dean or Kaylin, I'm not sure if you want to pick one out.
Yeah, Kaylin, did you spot anything there?
Maybe the HL7 format. So do we have a reader-writer for HL7 format? I don't think we have a designated reader-writer for that, but I think Trent is onto something. They should be able to use the XSD-driven XML reader to consume that, right?
That's correct. Yeah, we've tested that, and that works really well. So you can use XSD XML. That's a very good point. Thanks for that question. So with GML, you can read very complex schemas like CityGML just with the GML XSD reader. And in fact, you can even read and write CityGML 3 already with the CityGML, just the GML reader. It doesn't that doesn't take care of things like appearances. But so both the XSD XML and XSD GML reader writers are very powerful and can read almost any form of data. I'm just popping up for fun. This is just the stuff that the Plateau project that Takashi worked on. And so it's a city, and I guess you can translate the city in Japan. Yeah, you can select an individual building and get the data on that, and then I supposedly translate to English. There we go. So it just goes to show that this stuff does scale. This is city GML. So the FME was used to generate the city GML and then also to generate the I3S that's being served up. Oh no, sorry, this is cesium. Yeah.
All right. Thanks everyone so much for your time today, and to Dean and Kaylin and your time preparing today's content, and Trent as well for your help in the Q&A. I see we've gotten to all the questions, so I will just note that if you do have any other questions, please feel free to reach out to us. Don't hesitate, info@safe.com. And if you have a moment to fill out our webinar survey, we really appreciate any feedback. Thanks everyone. Hope you have a great rest of your day.
Yeah, thanks everyone for your time. And yeah, let us know if you have any XML or JSON challenges. Just reach out and yeah, we'll give you a hand.
Awesome. Bye for now.
Bye-bye.